One small update for the engine with a missing oil jet. It's not the time to remove piece connectors, it's not the time to open the block, because the sleeves, they need another 6 or 7 weeks, the pistons, they need 4 weeks, and there's some other couple of parts, couple of bolts, stock bolts that need to be ordered, that will gonna take at least 1 month. Alright, so it's not the priority, this one. Now what I'm doing, I'm checking the parts what I need to send at the machine shop, which parts need to go there for now, to prepare it at least, to don't run at the last minute for everything. If you remember, if you watch the first video, you're gonna see that the studs, they have all the threads out like this. You can measure it actually. I don't know if you can, I believe that you can see, because I was very close to the studs on the video. So you should be able to see the threads. So this is finished, it cannot go more down. Actually I bolted full down. Okay, 1 second. It cannot turn more, alright? And that's the washer here. That's the stud. So you see how many threads are out. Go watch the previous video, you'll understand what I'm saying. It's gonna make sense what I'm gonna say later. Now, here at the engine block, when I tried to remove the studs, the Allen, it was a little bit difficult. For me, how I'm removing the studs, before I pull out the cylinder head, I'm getting the Allen and I'm taking it out. That means I'm losing the nut first, 1.5 turn to be free, and then I'm start losing the Allen. And you cannot see any threads here. This is the side from the cylinder head, this is the side from the engine block. Now, if I get the stud and I put it inside here, I make one mark here with a white marker, because this is where it's starting engaging. Now I cannot pull it out now. There I can pull it out. There it's starting the threads. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm gonna call it 21. It can go a little bit more. Let us say 21, alright? It's 21 threads. It's 1.5. That means each revolution, it's moving the stud 1.5 millimeter inside. Let me remove the stud and I will explain my point. Okay, this I can bolt it by hand. I cannot bolt it in anywhere else by hand, because I don't know what they did. There I cannot bolt it more in. It's not turning, and now it's not even losing. Okay, what I did, like what I'm doing all the time, and that's why I'm double checking. I get the tool and I went inside and outside. Be careful on the Japanese engines. On this engine there is no problem. It's exactly the same threads. It's not more tight. It's exactly the same actually. I was also with the camera inside, just in case, to get some measurements, and then I took out the cylinder head. This no need anymore. Keep it there on the side with the rest. Now the height on the cylinder head from here till here, I have this bracket down to be nice and square. It's 72.2 millimeters. From here where it's stepping the washer till down there. Beautiful, beautiful. The stud, it's at 167 millimeters, 167.9 millimeters. 31.5 millimeters are the threads down. I'm talking about here, because 21 revolutions. So let me see. We have 21 multiply 1.5, 31.5 millimeters. Okay, you can measure it also. It's not a big deal. You can get a nut and you can measure it. 31.5 millimeters are the threads that goes inside the engine block. 24 millimeters, it's the upper one here, where is the nut and the washer. Plus 3 millimeter the washer, we're ending up 27 millimeters. Now, on the block, we have down here 8 millimeters that doesn't have a threads. Okay, The total length of the threads inside the engine block is 36.3 millimeters. Okay, the empty space that has here up is 34.7, and in total the depth is 79 millimeters. Now, what's my point? I'm gonna show you. Because I was thinking that they just didn't clean let us say, the threads on the engine block. That's why it's not going more inside and it's leaving so many threads outside. So if you have a calculator, you can do the same thing also by watching the video. So from the 36.3 millimeters here, we have engagement 31.5, because you cannot bolt it more down. It doesn't enter more down. All right. So we have 36.3 minus 31.5. That means 4.8 millimeters. It's remaining here. That means that this 4.8 millimeters, it does have engagement, the threads, because they cannot reach down. All right. So from now we have 4.8, I said, and we have 8 millimeters down. That's blank. All right. Now, from the 79 millimeters, the total height inside of the block, let us say, okay, minus 4.8 millimeters that we cannot thread over there. There are no available threads, okay, minus the 8 millimeters down on the bottom. It's not exactly 8. We are getting 66.2 millimeters. 66.2. All right. That means, what does mean that one? The stud, when you bolt it on the block, it's entering inside by 66.2 millimeters. All right. Then we are coming here on the stud, and we have, what do we have on the stud? We have total 167.9, and it's entering inside 66.2 minus 66.2, 101.7. That means it's staying outside of the block 101.7 millimeters. It's okay up to now. 101.7. Now 101.7. The cylinder head, it's 72.2 millimeters. If I retract from 101.7 the 72.2, you're gonna see how much you're gonna have here up. From 101, I was already there. 101.7 minus 72.2, it's 29.5. That's staying up here. I'm talking about here. And we have always, you will have plus minus 1 millimeter. It's not, I didn't make it precise. I can make it even more precise. So from 29.5 millimeters, we have 27 millimeter threads. That means in this measurement, I need 2.5 millimeters more threads here on the upper piece to be able to squeeze the cylinder head. Obviously, it was not the case. I believe that it was on the limit. Why I'm saying that? Because here, if you see all the studs, and if I adjust on how they're filling the threads inside, all the studs, you see this shiny mark here. This shiny mark is when you don't have more threads and you're trying to go more deep. That's what it is, this one, in all of them. You get my point? So how are we gonna solve this? It's very simple. It's not something difficult. I have done this before. It's not the first time. I'm gonna do it again. I'm gonna send to the machine shop, and they will gonna increase by 5 turns the threads here. And I will explain why I want to do that. 5 turns, 5 full revolutions, let us say, here down, it's 5 multiplied by 1.5, 7.5 millimeters. 7.5 millimeters, what will gonna give me this one? He'll gonna give me the 7.5 millimeters here up. So you're gonna be there. You're gonna be somewhere here. You're gonna see at the end how it's gonna be. Why I want the extra threads here? It's simple. If, let us say, for a reason, you resurface the deck, or you resurface the cylinder head, you're not gonna have threads. That means you're not gonna be able to bolt it down. It's already on the limit. That's why, like I said, that's why you see the shiny marks here. They try to use all the available threads. If you ask me, it's not right. But for some people, it is right. That's why they install it probably. So that's why what I want to do. 5 more threads, 7.5mm more threads here. It's only to go the stud more deep, more inside. I hope that I make myself clear on that. It will not gonna affect anything on the studs. I have done this before. It's not the first time. This is not happening from the ARP. I put a bet that this is being ordered from a different company. It's not on the catalog. That's what I'm saying. That's what I believe. So that's it. That's it, much. If you put more thick gasket, then yes, it makes sense. If you add, let us say, material on the cylinder head or on the deck, and you make it more thick, let us say, the cylinder head or the deck, then yes, it makes sense to have a space, let us say, to go more out the threads. But you get my picture, right? You get the picture, right? If you resurface, let us say, 0.25 the deck, 0.25 the cylinder head, you change the compression height of the piston to don't hit anywhere, and then you try to use the studs, I put a bet you're not going to be able to torque it down. Yeah, go watch the first video to see what I'm saying when I'm saying that all the threads are out, that's fully inside the nut. And like I said, all of them here where you see that shiny, that means whoever installed it, he didn't stop by hand, he put the Allen and he tried more to go more deep. All of them are like that. So it doesn't make any difference, even if I try to make, let us say, more threads inside, you're not gonna make any difference because you're not gonna enter more inside the stud. You're gonna enter only for the 31.5mm here. You're never gonna enter. I still have 4.8mm of threads more down, but I cannot use them. It's not going more. So the only solution here is to increase 5 turns, 7.5mm the threads here up, and everybody will be happy. That's it. Small update. Here I have one piston that I open, that I remove. It's a sample. That's what I'm doing now. I'm gonna bring also the oil pump to see how it looks like, if it grabs anything inside, just in case, if it has any scoring. Vacuum pump. Right now we are making a list of the parts that we need for this engine. Later on we're gonna see. Like I said, we are waiting the sleeves, we are doing the pistons, we are waiting the gaskets, the o-ring seals for all of the engine. What else do I remember anything else? No. Valve seals, all the valves are gonna come out. Exhaust hydraulic lifters, I'm gonna replace them. I'm not gonna keep the previous hydraulic lifters, so don't have any problem with the cylinder head in the future. All the valves are gonna be stripped off the cylinder head completely. Valve seals are gonna be replaced. You get the picture, right? One small update. Maybe if I saw something inside of the oil pump or on the vacuum pump, or if I see something on the high pressure pump or whatever, I'm gonna turn on the camera again. That's it for now. Thank you.